Hi guys, in this video lesson, we'll be discussing permutations and combinations, and a little bit of the fundamental counting principle. Suppose you pack 5 shirts and 3 pairs of shorts in your suitcase. If you randomly grab a shirt and a pair of shorts each morning, how many different combinations can you make? So this is the idea that you're just saying, oh, I've got 5 options here and 3 options here. So you're simply multiplying 5 by 3. You may have done this before. This is called the fundamental counting principle. It's a shorthand way of not actually counting all the combinations, but getting the number nonetheless. Example 2. Determine how many different computer 4-digit and 2-letter passwords are possible if you can repeat them or if you can't. Depends how specific this password needs to be. So in the first situation, I have 10 different digits to pick from, and I need 4 of those. Remember, 0 is considered a digit, so 0 through 9 makes 10 digits, and 2 letters. So when you multiply that out, you get 1,760,000. Part B, though, what if they can't be repeated? This right here is a great example of a permutation, something in which order matters. The order you put your password in matters. So it's a specific type of combination. So we could write this as 10p4, we're selecting 4 from 10, and 26p2. Whether you typed in this first expression or this combination of the second 2 expressions, you would get 3,276,000. Permutations and combinations are both based off the factorial that you learned in the last video. That permutation and combination feature can be found under statistics, or under math and then probability in a graphing calculator. It can also be found in graphing calculator apps. If you need one, just contact me and I can recommend some good ones. Example 3. Radio station call letters always consist of 4 letters, and they always begin with a K or a W. So let's think about how many different letter combinations are possible if letters can be repeated. Well, you always have those 2 to start, and then you have 26 for all of the remaining ones, which gives you 35,152. For the second, though, if they can't be repeated, you still have 2 to start, but once you've used a K or a W, you only have 25 left, then 24, then 23. Other ways you could get both of these, but these are the most intuitive ways. Example 4, similar. Suppose we want to figure out how many different 4-digit numbers can be formed from the digits 1, 2, 3, and 4, if digits can be repeated or if they can't. If they can, we have 4 options for the first, second, third, and fourth. 4 to the 4th power. If they can't be, well, we have 4 to start, but once we use a number, now we have 3, 2, and 1. Another way you could write this is for permutation of 4. We have 4 things, and we're selecting all 4 of them, and order matters. Another way you could write this is 4 factorial from that last video. All 3 of these expressions, if you type them in the calculator, will get you the same thing. Example 5. How many different 5-digit zip codes can be formed if digits can be repeated or if digits cannot be repeated? So if they can be repeated, we have 10 digits, 10 digits, 10 digits, 10 digits, and 10 digits. 10 to the 5th power. For part B, though, if they can't be repeated, we have 10, 9, 8, 7, 6. is really just a long way of saying 10p5. 10 digits to pick from. I'm picking 5 of them. Order matters. Example 6. In how many ways can 2 students out of a 25-member class be elected president and vice president? So there's 25 kids, and we pick 2. In this case, order matters because once you're president, you can't be vice president. So it's 25p2. So that's 600. You could also simply just multiply 25 by 24. Example 7. 8 basketball teams are in a tournament. Find the number of different ways that first, second, and third place can be decided. Assume we don't have any ties. So we have 8 teams to pick from, and we're picking 3 medals. So this is also 8 times 7 times 6. We get 336. Example 8. There are 15 members in a committee. Again, we're picking offices, so we have 4 to pick from. So we say, okay, I've got 15 people to pick from. And then out of that 15, I'm picking 4 because there's 4 positions. And I get 32,760. Example 9. This one's a little different because the baseball coach is using some strategy. He's picking a batting order. He's got 9 players, but he doesn't want the pitcher to be one of the first 4 at bat. So when he creates this batting order, because he's not using the pitcher, he has 8 to start from. But then once he picks one player, he has 1 less, and 1 less, and 1 less. Oh, the first 4 are up, so now he can throw the pitcher back in. 1 less, 1 less, 1 less, and 1 less. And you could count and say, oh, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, I have the same number of numbers as I do players. When I do this, I get 201,600. Example 10. So in examples 10 and 11, when they talk about distinguishable permutations of the letters in different words, they kind of want you to think about it like magnetic letters that you might see on a refrigerator. If I swap 2 A magnets, one for the other, you're not really going to be able to tell because it's still an A magnet. Distinguishable means noticeable or different. So how many different ways can I arrange these 5 letters? Well, 5p5 or 5 factorial, which is 120. Mississippi, however, is different. In Texas, all the letters were different. In Mississippi, we have a lot of repeats. We have 11 letters. But if you count them out, we have 1, 2, 3, 4 I's. And we have 1, 2, 3, 4 S's. And we have 2 P's. So if we do 11 factorial divided by 4 factorial, and 2 factorial, and those parentheses are really, really important, we get 34,650. Example 12. A committee of 5 people is to be chosen from a group of 20 people, 12 of which are men and 8 are women. If the order in which they are chosen isn't really important, we're just grabbing people. How many different 5-people committees are possible? So this is a great example of a combination. Order doesn't matter. So we have 20 people to pick from, and we just need to pick 5. We'd use that combination feature in a calculator, and we get 15,504. Part B is a little different because we're being more specific. We're saying we want 3 men and 2 women. So out of the 12, we're picking 3 men, and out of the 8, we're picking 2 women. It's an end probability. So we get 6,160. Example 13. An ice cream shop has a choice of 10 toppings. In how many different ways can you choose 3 different toppings for your ice cream? So this is another example of a combination. Order doesn't matter. We have 10 toppings, and we're just picking 3 of them. So that makes 120. In part B, though, suppose you can afford at most 4 toppings. How many different types of ice cream sundaes can you order? Well, if it's at most 4, we could order no toppings. We're really boring and we just like vanilla. Or we could consider the combination where we order 1 topping, or 2, or 3, or 4. And we could come up with 386 different combinations. Example 14. An organization contains 30 people, 20 of which are women. How many different committees of 6 people can be chosen? So, out of the 30, we're picking 6. The order doesn't matter, we're just picking 6. So we get 593,775. In part B, how many different committees of 6 people can be chosen in which 4 are women and 2 are men? So we're going to say, okay, out of the 20 women, we're picking 4. And out of the remaining 10 men, we're picking 2. So we get 218,025. Plenty of combinations. Again, order doesn't matter, so it's not a permutation. 15. A pizza shop offers 12 different toppings. How many different 3-topping pizzas can be formed with 12 toppings? So, when they say assuming no topping is used twice, they're not saying order matters. They're just trying to make sure you don't come up with a weird combination like pepperoni, pepperoni, pepperoni. So, in this case, it's just simply we're picking from the 12 3 toppings. And 16, 9 people in your class want to be on a 5-person bowling team to represent the class. How many different teams can be chosen? So we have 9 people to pick from, and we're choosing 5. 126. 17. A high school football team has 2 centers, 9 linemen, who can either play guard or tackle, 2 quarterbacks, 5 halfbacks, 5 ends, and 6 fullbacks. The coach uses 1 center, 4 linemen, 2 ends, 2 halfbacks, 1 quarterback, and 1 fullback. How many different ways can the offensive unit be selected? So this is more reading comprehension than anything. From 2, you're picking 1. From 9, you're picking 4. From 2 quarterbacks, you're picking 1. From 5 halfbacks, you're picking 2. From the 5 ends, you're picking 2. And from the 6 fullbacks, you're picking 1. So you end up with 302,400. Lots of combinations. Okay, so for this example, there's really 4 different parts going on. So it says find the number of possible 3-hand cards that contain 3 red cards, 3 aces, 3 face, and 3 of one kind. So red cards, there's 52 cards in the deck, 26 are red. So this is going to be 26. Ooh, that's a horrible 26. 26C3, 2,600. For part B, 3 aces. Well, there's 4 aces in a deck, and you're picking 3. For part C, 3 face cards. There are 12 face cards in a deck, and you're picking 3. And for D, this kind of has 2 parts. It's 3 of one kind. So out of the 13 different kinds of cards there are. You're picking one. And from those 4 cards, the 4 kings or 4 queens, you're picking 3 of those. So in 19, we're taking the permutations and combinations from this section and combining them with the probability of last section. So 7 letters are chosen, one at a time, at random from those in the word English. What's the probability that they're going to be chosen in alphabetical order? Well, there's only one way they can be in alphabetical order. So we just need to figure out how many different ways we could combine those. So we have 7 letters and we want to use all of them, or you could think of it as 7 factorial. So 1 over 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. Or use the button on your calculator and you get 5,004. What are the odds that the first letter will be a vowel? Well, there's 2 vowels, so 2 out of 7. Last example. For next year's schedule of classes, math, English, history, and science are each scheduled during the first 4 periods of the day. Not likely here, but could happen. What is the probability that English, math, science, and history will be scheduled in that order? Well, there's only one way they could be in that order, the way listed, out of all the different ways they could be arranged. And 4 factorial is 4 times 3, 12 times 2, 24 times 1, 24. So I know this was a ton of examples, but I did want to give you breadth. If you're still feeling a little confused, or if you go to do the assignments and it's still not quite clicking for you, I put links to a few other different people explaining similar things. And as always, I'm happy to help if you contact me. You'll also be excited to know you are not doing cons this week. I found some other ways to assess you this week. I wasn't a big fan of the con goals, so this is also the last week that you have assignments outside of your final project. So hopefully you've all gotten your questions in and approved. So I'm going to be sending out that survey to the student body either today or tomorrow.